So there comes the solution of the previous question. We need two property tables. The properties of oil at 80 degrees Celsius are table A16. So from this table we can got all this value. Rho is equal to 852 kg per meter cube. Prandtl number is equal to 490. K is equal to 0.138 watt per meter degree Celsius. V is equal to 37.5 into 10 to the power minus 6 meter square per second. So the analysis is the schematic of the heat exchanger is given in figure 13.10. The overall heat transfer coefficient U can be determined from equation 13.5. This equation 1 by U is equal to 1 by H inner plus 1 by H outer, where H inner and H outer are the convection heat transfer coefficients inside and outside the tube, respectively, which are to be determined using the forced convection relations. The hydraulic diameter for a circular tube is the diameter of the tube itself. That means dH hydraulic diameter is equal to d, that means 0.02 meter. The mean velocity of water in the tube and the Reynolds number are mean velocity Vm is equal to m dot divided by rho AC. M dot divided by rho AC means 1 by 4 pi d square. The value of m dot is equal to 0.5 kg per second. The value of rho is 990 kg per meter cube into 1 by 4 into pi 3.1416 into d, that means 0.02 meter square. After calculation we can say this: the mean velocity of water in the tube is 1.61 meter per second. And the next one, the Reynolds number is equal to mean velocity into hydraulic diameter divided by V. So mean velocity is 1.61 meter per second, hydraulic diameter is 0.02 meter, similar to d, and V is equal to 0.602 into 10 to the power minus 6 meter square per second. So from this we can write Reynolds number is 53,490, which is greater than 4,000. Therefore, the flow of water is turbulent, not laminar. Assuming the flow to be fully developed, the Nusselt number can be determined from this equation. Nu is equal to HdH divided by K, that is equal to 0.023. Reynolds number power 0.8, Parrot's number power 0.4 for cooling is equal to 0.023 into 0.4 for heating, is equal to 0.023 into Reynolds number 53,490 power 0.8, Parrot's number 3.91 power 0.4. So that means Nusselt number is 240 into 6, 240.6. Then H is equal to K by dH Nu. So the value of K is 0.637 watt per meter square degree Celsius. dH means 0.02 meter and Nusselt number is 240.6. So the value of H is 6,663 watt per meter square degree Celsius. Now we repeat the analysis above for the oil. The properties of oil at 80 degrees Celsius are: rho is equal to 852 kg per meter cube, V is equal to 37.5 into 10 to the power 6 meter squared per second, K is equal to 0.0138 watt per meter degree Celsius, and Prandtl number is 490. So from this information or data, the hydraulic diameter for the annular space is dH is equal to d outer minus d inner, that means 0.03 minus 0.02 is equal to 0.01 meter. And the mean velocity and the Reynolds number in this case are almost similar to the previous one, just here is the confirmation. M dot is 0.8 kg per second, rho is equal to 852, and pi d O square minus di square, so 0.03 square minus 0.02 square. And after calculation we can say this: the mean velocity is 2.39 meter per second, and like the previous one, the Reynolds number is 637, which is less than 4,000. That means laminar flow. Therefore the flow of oil is laminar, not turbulent. Assuming fully developed flow, the Nusselt number on the tube side of the annular space NUI corresponding to di by do, that means 0.02 divided by 0.03 is equal to 0.667, can be determined from table 13.3 by interpolation. To be Nusselt number is 5.45. and HO is equal to K by dH Nu. The value of K is 0.138 watt per meter degree Celsius. dH means 0.01 meter hydraulic diameter, and Nusselt number is 5.45. So after calculation, we can say that HO is equal to 75.2 watt per meter square degree Celsius. Then the overall heat transfer coefficient for this heat exchanger becomes U is equal to 1 by HI plus 1 by HO. So 1 by HI means 7663 watt per meter square degree Celsius, and 1 by HO means 75.2 watt per meter square degree Celsius. So after calculation, we find the overall heat transfer coefficient for this heat exchangers, and this is 74.5 watt per meter square degree Celsius.